Here are examples to draw Lewis structures using the steps that I gave you. You should have gotten this as a handout. We're just going to follow these steps. For the first step, it says arrange the atoms, placing the first atom listed as the center, everything else surrounding it. There is an exception to this. Hydrogen cannot be the center atom. So if the first element listed as hydrogen, you're going to put the second atom as the center atom. So if we look at this first example here, carbon is the first element, and we're going to put carbon here. We're going to put all the elements around it. So we have 3 hydrogens and a chlorine. It really doesn't matter which side you put things where. The next rule, it says count the number of valence electrons for the atoms present. Well, I have carbon that has 4 valence electrons, and I have 1, 2, 3 hydrogens that each have 1 valence electron. And I have 1 chlorine that has 7 valence electrons. So doing the math, this adds up to 14 valence electrons I have available. The next thing, it says place 2 electrons between the center atom and each outer atom, or you can draw a dash to represent 2 electrons. I like to use dashes. So each of these dashes represent 2 electrons connecting those elements to the center atom. The next thing we're going to do is complete the octet of each of the outside atoms. We aren't doing this to the center atom. We're going to deal with the center atom later. We're going to do this by adding dots in pairs. However, hydrogen only wants 2 electrons. It doesn't want 8. So I'm not adding extra electrons to hydrogens when I do this. So I have 3 hydrogens that I'm not adding any extra electrons to, but the chlorine does need 8. It has 2 already from this bond, and so I need to add 3 more pairs to give it 6 more electrons. The next thing I'm going to do is I'm going to subtract the number of electrons I've drawn from the number of valence electrons I had available. So I've drawn, counting each of these as 2, 4, 6, 8, 10, 12, 14. And so I don't have any valence electrons left. The second to last thing here, it says if there's any leftover electrons. We don't have any leftover electrons, so we don't need to worry about that. The next one is if the center doesn't have an octet. So now we look at the center atom and see if it has 8. 2, 4, 6, 8 around it. It does, so I don't need to do anything more. And this is the Lewis structure for that molecule. Let's look at another example. So we have here HCN. Remember, following the steps, the first step says put the first atom in the center unless it's hydrogen. Because it's hydrogen here, I'm not going to put it in the center. I'm going to go to the second element, which is carbon, and I'm going to put that in the center. So I'm going to have carbon here. Then I'm going to put the hydrogen and nitrogen around it. I just usually evenly put them around. Then I'm going to count how many valence electrons I have available. Well, I have 1 from the hydrogen, 4 from the carbon, and 5 from the nitrogen, giving me a total of 10 valence electrons. Then I'm going to connect the outer electrons to the center with using a dash. Remember, each dash represents 2 electrons. I'm going to complete the octet on the outside elements. Hydrogen doesn't want a complete octet, so I'm only going to do this for nitrogen. So I'm going to complete it by adding 3 pairs, which will give it a total of 8 electrons, because remember this line counts as 2 by it already. Then I'm going to count how many electrons I've used. So I've got 2, 4, 6, 8, 10. Again, I have 0 electrons left over. But now if I look at the center atom, it only has 4 electrons around it. So now we're going to go to this last thing to see what happens if it doesn't have 8. If the center atom doesn't have 8, we're going to either form a double or a triple bond as needed by sharing electrons from the exterior atoms. So we're going to look at the exterior atoms. We only have this one that has electrons to share. So we're going to share them. So I'm going to move a pair of electrons here and make it become a bond. So now I have this. Does my carbon now have 8 around it? 2, 4, 6. It doesn't, so I'm going to share another pair. And now I have this. When you're sharing 2 pairs like this, that's called a double bond. This is called a triple bond. This carbon now has 8 around it. It has 6 from these, so 2, 4, 6, and then another 2 over here, giving it 8 valence electrons around the carbon. And so now that it has 8, that is its Lewis structure. Okay, let's look at the next example. the next example, we got good old water here. For water, hydrogen can't be the center, so I'm going to put oxygen in the center. I'm going to put the hydrogens around it. I'm going to count how many valence electrons I have available. Well, I have two hydrogens that each have one valence electron, and an oxygen that has 6. So I have a total of 8 valence electrons available. I'm going to attach everything to the center, and I'm going to complete the octets of everything around the center. But because the only things around the center are hydrogens, I'm not going to add any electrons. So I'm going to count how many I've drawn now. 2, 4. So I've only drawn 4. So that means I have 4 electrons left over. So going back to our rules, it says if there's any leftover electrons, which is what we have here, we put them in pairs on the center atom. So since we have 4, we're going to have 2 pairs of 2. And again, I'm just evenly distributing those. And so that's going to give me my Lewis structure for water. So on this last example here of SO4 minus 2, we're going to follow the same steps. Oh, I forgot to look at water. I should have done this and confirmed that it had 8 around the center atom still. It does. It has 2, 4, 6, 8. So that's how I know I'm done. All right, now back to this. When we have a charge, I'm going to show you how we deal with that. We're going to do all the steps the same. I'm going to show you where we have different steps. So I'm going to put the sulfur in the center. I'm going to put the 4 oxygens around it. I'm going to count how many valence electrons I have. This is one of the places where I'm going to change what I do. I'm going to say, okay, I have 6 valence electrons from the sulfur. I have 4 oxygens that each have 6. And then the other thing is it has a charge. -2 means it gained 2 electrons. So I'm going to add 2 electrons to my valence electron count. If it had a positive charge, I would subtract that many electrons from the count because that's what a positive means. Doing all the math here, let's see if I can do the math here. 4 times 6 is 24, plus 6 is 30, plus 2 is 32 valence electrons. Okay, that completes that step. Next step, I'm going to attach everything from the center to the outer electrons. I'm going to complete the octet on all the outer electrons. So I'm adding 3 pairs to each of these oxygens. I'm going to count how many electrons I'm using. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So I've used all of my 32 electrons, so I don't have any electrons to put in the center. So now I'm going to look at my center and see if it has 8. 2, 4, 6, 8. And it does, but we're not done yet. When you have a charged particle, you need to indicate that it has gained or lost electrons overall. And so I'm going to put this in brackets and then put -2 so everyone who looks at it knows that that molecule has an extra 2 electrons in it to make that structure. And that's how I would draw that. Okay, so I'm going to have you try some of these on your own now.